All right, number 9, we want to write the equation that represents the linear approximation. Use that linear approximation to estimate the given quantity and then compute the percent error. So our f of x is cosecant, and we're using a at pi over 2. All right, so just a reminder, linear approximation, f of a plus f prime times x minus a. So we need to plug in pi half, plug in it to the derivative, and then we can solve it. So let's plug it in. F of pi over 2 is equal to CSC of pi over 2. So cosecant, cosecant comes from sine, so this is the same as 1 over sine. Sine of pi half from the unit circle. Pi half is here. Ordered pair is 0, 1. Sine is corresponding to the y coordinate. So y is 1. So 1 divided by 1, we just get 1. So f of pi over 2 is equal to 1 over 1, which is just 1. So that's my f of a is 1. We're going to find the derivative. So derivative of cosecant, it's 1. I'm going to use our trig cheat sheet. That's not one of those that is committed to memory. So I'm going back to our course, pull up our trig cheat sheet, some homework videos, cheat sheets, handouts, and we can look at the derivatives or differentiation. Both of them should have it. Differentiation has a little bit more detail. All right, so cosecant, derivative of cosecant is negative cosecant times cotangent. Okay, so negative cosecant times cotangent. All right, so once we have this, we are now going to plug in pi half to this expression as well. All right, so we've already done cosecant of pi. 1 over sine is just 1. Since it's negative, we'll get a negative 1 for this part times this part. So cotangent is coming from cosine divided by sine. So cosine is the x coordinate, so that is 0. Sine is the y, so 0 divided by 1 is 0. So this whole thing is going to be 1 times 0, which just gives me 0. So my slope gives me 0. So when I do my linear approximation now and plug everything in, f of a, which is f of pi over 2, is just 1. My f prime of a, which is f prime of pi over 2, ended up being negative 1 times 0, which just gives me 0, times x minus pi over 2. Now 0 times, it don't matter what this is, going to be 0. So we just end up with 1. Linear approximation is 1 at that point. Sorry, I didn't realize that was up there in the way. All right, so when we are using linear approximation to estimate f of 1.62, we would plug in 1.62 for x. Well, there's no x over here, so it's still just 1 when we're using our linear approximation to approximate that, because the x got zeroed out. So our linear approximation is still just 1. All right, now we're going to do percent error. So remember, it's going to be estimate minus the exact over exact, all positive, times 100. All right, so we're going to just use calculator, and we'll just input those exact values. So the estimate alpha y equal, enter, make a fraction. So we got 1 minus, now the exact is going to be this function plugging in the 1.62. So we don't have a button for cosecant. So I'm going to have to do parentheses. I'm going to have to make another fraction. I'm going to do 1 divided by, now since cosecant is 1 over sine, I'm going to type in sine. So 1 divided by sine of 1.62. And then close again. So that, all right, so this is the numerator 1, the linear approximation minus the exact, and then all over the exact. So that's going to be 1 divided by sine 1.62. And you want to do this in the calculator because you're going to get some decimal points. And if you round it, it's going to throw your answer off and it'll be incorrect. So you want to do all this and then round at the very end. All right, so we get a negative 0.001. If you multiply this by 100, decimal place stops right here. So we're looking at 0.121, negative 0.121%. Well, we want to make that positive, sorry, absolute value. So it's going to be 0.121% because I didn't do absolute value of this whole thing. So 0.121. 3 decimal places, 0.121.